We're going to go over the steps on how to make a simple alignment. First, we're going to do the alignment and then build a tree from that. So we're going to go open our files, and we're going to find out where our files reside. So I have them all here under sequences. You would have done this ahead of time, of course, put them in some place. As you can see here, I have a bunch of GenBank files, and we'll talk about that in a little bit. So I'm just going to choose on all these GenBank files. Okay. And now it's going to give us a pop-up that is going to ask us a question regarding how we're going to handle these sequences. So here's the pop-up. It often doesn't come up and it's hidden, but we're going to treat them as separate sequencing mode. You can merge sequences or join the alignment, which is what we're going to do anyway, but we'll skip through that and just treat them as single sequences. So you can see how they're annotated here. So they show up here, and you can see that each one of these files is about 16,000 base pairs. There's the one exception, which is just a piece. If I actually put it, that's the Billy Ape. And the Billy Ape one, if we look at this one, is not circular because it is in fact only one single sequence. The reason why GenBank files are useful is because when you go back to them, you can look at the different annotation types here, where all these genes are annotated. You can shrink that circular view and you can see where the CDs are. These are all coding sequences. So what we're going to do is actually select all of these, and we're just going to right click on them and export to alignment. And we're going to send it in this sequence here. We're going to rename it. So let's just call it alignment. Alignment. And we'll use this file format, which is fine. And here, it actually didn't do an alignment, you can see. So what we want to do is actually go to the alignment, which is here, and we can actually force the alignment on there. So here we'll just once again we'll choose align, and there's the different forms of alignment algorithms that we can use. Make sure these are installed on your system beforehand and linked to Ugene. So we're going to choose align with muscle. We can use cluster omega as well, but we'll just use muscle. And it's going to ask us a bunch of things, and we'll just go with the standard alignment options, and we'll press align. Notice here, these are large sequences, so it's doing this. Don't try to do it again. You'll waste your time. Okay, so now that it's actually finished, this actually took a while, and I never suggest doing a large set of sequences like this. You can see how it's performed the alignment. And now it looks like a real alignment. Notice that all these dashes correspond to this one figure or sequence here that corresponds to that partial sequence to begin with. So if we go through this, you can see how it has a line between these different species. And now what we can do is build a tree. To build a tree, you can click on this icon here, and that will help us start to build a tree. We can say build a tree. And now we have to pick an algorithm. Once again, we have to ensure that these things are loaded in our system beforehand. And I tend to use a phi-ml or maximum likelihood for this case, and go with the default. Once again, it's going to take and save this into a space, and it's going to be called a Newark file, I should say, NWK. So now we're going to build this. And after we build this, it'll show up over here off to the side and as a separate file. And here we are, and you can see the general outline here of what the tree looks like. Or we can view it by looking at our alignment, double-clicking there. And you can see, once again, it's inconvenient because these names don't really correspond to something useful except for what is mentioned in their GenBank files. But if we look at it and try to alias this, NC001643 is pan troglodytes, and then AF3612 is Billy Ape. So you can see that the Billy Ape and this chimp are extremely closely related, followed by HM01, which is the other type of chimpanzee. So it's most likely that this Billy Ape, this mythical lion-killing ape, is actually one of these pan troglodytes. And if we look at it, here's another branch that has two very similar ones, HQ26, H2Q609, which is the Homo sapiens, and FR69, which we can see is this Denisovan. And from this, you can actually go back to the file and further edit it, especially replacing the names.